Hello students, welcome back to our next screencast. This one's interesting. The topic is solving systems by substitution. So we are going to use that unbelievably mind-blowing new method of solving a system of linear equations by substitution. But here's the thing. It is up to us to set up the system first. In other words, we have to establish, based on the situation here that's about drumsticks, what are the two equations? Now I'm going to show you some tricks in doing it for this type of problem. So here's the situation. A drummer is stocking up on drumsticks and brushes. Here are the drumsticks, you know what those do, but the brushes, just so you have a point of reference, you've heard the sound of the brush along the drum. It makes kind of that longer sound. Sounds pretty cool, but those are the brushes. So the drummer's stocking up on drumsticks and brushes. The wood sticks that he buys are $10.50 a pair, and the brushes are $24 a pair. He ends up spending $90 on sticks and brushes and buys 2 times as many pairs of sticks as brushes. That is an extremely important sentence that we're going to come back to in just a moment. How many pairs of sticks and brushes did he buy? Well, we could use X and Y because we're buying 2 separate items, sticks and brushes. So we could say X and Y, but you know what? Because we get to set it up on our own, they didn't really tell us we had to use specific variables. Let's just keep it simple for ourselves, and let's say S is the number of pairs of, let's say sticks, because it's S. That'll help us out in setting this thing up. And let's let B be the number of pairs of, that's right, you guessed it, brushes. We have to figure out how many pairs of sticks and how many pairs of brushes that this drummer happens to be buying, knowing that they have $90 in your pocket. So there's a few combinations that we can do. Well, it's really up to us to determine what specific combination of pairs of sticks and brushes based on very specific information in the problem. And probably the most crucial piece of information in here is the fact that this drummer bought 2 times as many pairs of sticks as brushes. We'll explore that in just a moment. Now, when you get a problem like this, and you will see problems like this again, specifically in just a few moments when you're given yours that you need to solve, these are the type of problems that I like to call cost and quantity style problems. Because you're going to set up 2 equations to make this system of linear equations. And one of the equations in the system is going to represent total cost. In other words, all the money that's being passed back and forth in this situation, in this transaction, will be represented with one equation, which we'll set up first, and then a second equation that doesn't represent necessarily the cost, but how many of each item. And the information right in here is all we need. We just need to know how, as good mathematicians, to decipher it into mathematical symbols. And we're going to do that right here, right now. So let's begin. Let's first start with the cost equation, which, if you ask my opinion, is always an easier equation to set up. Now, as you practice with these, maybe you'll find the quantity equation a little bit easier. Let's find out. Okay, so what information do we need to set up a cost equation? Well, we need things that have to do with money. We know that the sticks are $10.50 a pair. We know that the brushes are $24 a pair. And we know he has $90 in his pocket to spend on sticks and brushes. So, using the logic that we have been honing and practicing and working with single linear equations, we can apply it here. We know that it's $10.50 for a pair of brushes. Sticks. $10.50 for a pair of sticks. So therefore, if he bought 1 pair of sticks, that's $10.50 times 1. If he bought 2 pairs of sticks, that's $10.50 times 2. 3 pairs of sticks, that's $10.50 times 3. You know where this is going. You've heard me say it before. But we don't know how many pairs of sticks he is buying. We simply know that he is buying some unknown S number of pairs of sticks. So therefore, we take $10.50 and multiply it by S. So I'm going to write 10.5 S, which represents the total cost of just the sticks. How many sticks you buy? Multiplied by $10.50, because that's how much each pair is. All right, good. Now, using that very same logic, we apply it to the brushes, because the brushes are $24 a pair. So if he buys 1 pair, that's 24 times 1. 2 pairs, that's 24 times 2. 3 pairs, that's 24 times 3. On and on and on. B number of pairs, that's 24 times B. In other words, 24B. All right, so what we have to establish next is what little symbol is going to go right in between these two terms, the 10.5s and the 24b. Well, this, of course, is a total cost. We're buying both the sticks and the brushes together, so therefore we're going to add these two together because that whole thing is going to equal how much cash that we happen to have in our pockets, which is $90. So the whole thing will equal $90. And thus, we have just established our cost equation. And now you probably see why I call it the cost equation, because all the numbers here represent how much money is being spent on the sticks and the brushes for a total of $90. So nothing but money in this situation is being represented, nothing but cost. All right, good. Now what we have to do is establish the quantity situation. And that one is a little bit more, well, challenging. I don't know. Let's find out. Where in here does it talk about not necessarily how much it costs to buy the sticks and brushes, but rather how many sticks and brushes were bought? Right here. He buys 2 times as many pairs of sticks as brushes. Now, deciphering that takes a little bit of logic. The first question we ask ourselves when we're trying to establish this quantity equation is, which did he buy more of? If he bought 2 times as many pairs of sticks as brushes, did he buy more brushes or did he buy more sticks? He bought 2 times as many pairs of sticks as brushes. So therefore, he bought more sticks, which means he bought less brushes. So here's how I'm going to start this one out. I'm going to start off nice and simple and say B, the brushes, equal S. Now we know that's not entirely true. We need to modify one of these terms, one of these variables, either the B or the S, to represent that one is double the amount of the other. Now, which one is double? Now we know doubling the amount is the same as 2 times as many. So we're going to need a coefficient of 2, either in front of the B or in front of the S. But not both. Only one or the other. Well, which one would make sense in this situation here? Give yourself a moment to think about that. Would 2B equal S, or would 2S equal B? Here's how I recommend you think about it further if you haven't realized it yet. Because we know there are more sticks than brushes, this number of brushes has to be a lower number than the number of sticks. Thus, we need to bring this number up so that it does equal the number of sticks. In other words, if he bought 2 times as many sticks as brushes, then 2 times the number of brushes would equal the number of sticks. He bought 2 times as many pairs of sticks as brushes. So therefore, the sticks are more than the brushes. So if we double the number of brushes, we have the number of sticks. I'll let that sink in for a moment. And if the logic makes sense, and you're comfortable with it, we will move on. Here, for those that are still kind of confused by this, why 2B is equal to S is accurate and 2S equals B is not. Let's say that he bought, and this is just, we haven't solved it yet, let's say he bought, 8 pairs of brushes. Well, then 2 times 8 would equal 16. So that would represent that he bought 8 brushes and 16 pairs of sticks. Now, if he bought 8 brushes and that means he bought 16 pairs of sticks, does that make sense that he bought 2 times as many sticks as brushes? Yeah, because look, 16 is 2 times 8. So therefore, 16 would be accurate and 8 would be accurate. You see, you take the number of brushes, you double it, and you get the number of sticks. See, that's what this part of the sentence is saying. Buys 2 times as many pairs of sticks as brushes. And if you go too fast in thinking about it, you might clearly say, oh, if he buys 2 times as many pairs of sticks, that's 2S. I just have to double the pairs of sticks. No. You have to double the pairs of brushes. So now we have both of our equations. Hopefully that did make more sense why it's 2B is equal to S. So We have both equations in our system, the cost equation, which is 10.5s plus 24b is equal to 90, and now finally our quantity equation, which is 2b is equal to s. Let's start using this. So here's our system again in all its glory. 10.5s plus 24b is equal to 90, and 2b is equal to s. Now let's solve it using substitution. All right, now before we do, keep in mind you could have solved this using graphing techniques like we first saw, but that would be kind of annoying. It really would, especially since we have some decimals involved here. And when you're dealing with cash, you're probably going to have decimals because of cents that are involved. So I think substitution would be the best method for this one. Now, again, don't get me wrong, this could be solved by graphing, but it's going to be a far more involved process. By substitution, you'll see it's nice and clean and quick. Here we go. Let's look at both of these equations. Both of these, this one and this one. We have two variables. We have a b and we have an s. Which variable is kind of already in its own way sort of already solved for? In other words, isolated already. That's right, it's s right here in the second equation. S in the second equation is already solved for, quote unquote. It's isolated. We know s is equal to 2b. So let's take this entire expression of 2b and let's send it into the other equation's variable s. All right, so let's do exactly that. In other words, what I'm literally going to do is I'm going to remove this s back here. Let's put that off to the side here. Let's put it up on the drum there. There, now it's resting on the drum. We're going to replace it with the entire quantity of 2b. Notice I did put parentheses around it. Please, when you're always substituting, especially with this method, especially, in which you're not just replacing a single number or a single digit, you're replacing an entire term or an entire expression, in this case just a single term, 2b, put parentheses around it. It helps you to know that you are dealing with multiplication. And now it's almost like we're back into, last year's 7th grade math class, in which now we only have technically one variable. Both of them are b, so that is technically one variable because we have like terms which we'll combine in just a moment. Let's actually do the math. 10.5 times 2b. Well, of course, that's 21b. And we're still adding that to 24b, and we're kind of home free when it comes to solving for the number of brushes. 21 plus 24b we know is 45b, and that's equal to 90. And then we can clearly see that b can only be one number, 90 divided by 45, which is 2. Thus, we have solved for the number of pairs of brushes that we've solved. We know for a fact it is 2 pairs of brushes. Now, we're halfway done because we also have to figure out how many sticks, how many pairs of sticks that this drummer happened to have purchased. But see, here's the really, really nice thing about doing that second substitution, is that where in the world should we take this to? We know 2 is now equal to b, or b is equal to 2 rather. So therefore this 2, should we put it in front of this b, replace this b with it, or should we replace this b with it? The answer is it doesn't matter. Either one will get you the correct s, the correct number of sticks. However, for your own sanity, ask yourself which one kind of seems easier for you to substitute into, and yeah, I would definitely say that 2b is equal to s is a far simpler looking equation than this other one that we established. The quantity equation is simpler looking. So let's go ahead and take this 2, which is b, and let's send it all the way right there into that b. So let's make that substitution. I'm going to remove this b, let's put that over there in the corner as well, and I'm going to replace it with 2. Alright, so please keep in mind I did put parentheses around it again, always do that. Wow, look at how easy that is, 2 times 2. So if he bought 2 pairs of brushes, he clearly bought 4 pairs of sticks. Not bad. So we got that 4 is equal to s. Okay, now remember what I said earlier. Didn't matter where you inserted this 2 right here. If I put it into the other equation where I had a b, would I still get 4 as s? The answer is yes. Now, bear with me for a moment. I'm going to show you that real quick. So again, if another student or someone sitting next to you decide to, you know what, I'm going to use kind of the more complicated cost equation to solve for S, you can still remove this B and replace it with the 2 right there. So let's do that. Remember to still use parentheses. And let's do the math to solve for 10.5 S. Let's solve for S. So 10.5 S stays the way it is. And that, of course, is plus 24 plus, or times 2 is 48, is equal to 90, and then of course we subtract from both sides the 48, and 90 minus 48, that's right, it's 42, and then you take 42 and you divide it by 10.5, and feel free to confirm this on your own, but I can assure you 42 divided by 10.5 is, once again, the very same 4 that we got earlier. So no matter how you look at it, this person happens to be buying 2 pairs of brushes and 4 pairs of sticks, thus totaling $90. So after doing all that work, we realized that we bought B, 2 pairs of brushes, and we bought 4 S pairs of sticks. Now again, just so that we are confirming that our numbers are accurate, let's go ahead and check our work. We can check it into both equations, but let's check it first into the cost equation, which, don't forget, was. So what we're going to do is we are going to remove S, and that's the pairs of sticks, so we're going to replace that with 4. And we're going to remove this B, and we know that's the pairs of brushes, so that's 2. Again, don't forget, parentheses. Let's see if, according to our calculations, if we buy 10 pairs of sticks at $10.50, and we buy 2 pairs of brushes at $24 each, that does, in fact, equal $90. And absolutely it does, because 10.5 times 4 is 42, and 24 times 2 we know is 48. We're still adding those together, and ideally it equals 90, and look at that, 42 plus 48 does, in fact, equal 90, so nice work. We know we got the correct answer with 2 pairs of brushes and 4 pairs of sticks. Nice work. All right, now it is time for yours, and this one's very similar, except in a different situation. Here goes. This one's about fundraising. A wilderness group is selling cans of nuts and boxes of microwavable popcorn to raise money for a trip. A can of nuts sells for $4.50, and a box of microwavable popcorn sells for $3. The group sells $252, wow, in nuts and popcorn, and they sell twice as many boxes of popcorn as cans of nuts. Be careful with that part right there, crucial information. The nice thing about this problem is it's broken down into 3, as you can see, steps for you, and each step will be used in the next step. So they give you the variables in part A. It says let X be the number of boxes of popcorn, so X will be popcorn, and let Y be the number of cans of nuts, so Y are the nuts sold. Write an equation that relates the number of boxes of popcorn sold to the number of cans of nuts sold. All right, let me give you a little hint here. Part A is asking you to first set up the quantity equation. Yeah, that's right. Part A is the quantity equation, because notice it's saying not about the cost, but it's saying the number of boxes of popcorn sold to the number of cans of nuts sold. It's not saying how much money was exchanged here and there. It's saying how many of the boxes and how many of the cans of nuts were sold. So part A is the quantity equation. Part B, however, says write an equation that gives the total amount of money made in terms of X and Y. Now they're specifically saying how much cash was made, and of course that one is going to be the cost equation. And all the information that you need to set up both equations in your system is right in the situation above. And then part C is pretty much asking you to solve the linear system. How many boxes of popcorn did the group sell? How many cans of nuts did the group sell? There you go, folks. So this one's broken down into 3 steps. First, the quantity equation, then the cost equation, and then actually find out, based on the quantity and the cost equations, how much popcorn and nuts were sold. All right, good job, everyone. If you have any questions, don't hesitate to email. Take care.